Hi, welcome back to AT Math. Today, 8-2, factoring by GCF, which is greatest common factor. Why it's more fun than winning a game of tic-tac-toe. Now, today you can follow on page 531, which would be right here, where you see factoring by greatest common factor. Now, let's take the example they give, 4x squared minus 3x. The question is, what's the same? What's the greatest common factor between both terms? It looks like both have an x, which is 4x squared, and minus 3x. So you're basically dividing both terms by x. So I'll take an x out of here, I'll take an x out of here. So I divide both by an x. This leaves 4x and negative 3. And therefore, where did the x you divided go? You put it on the outside. You took an x out of each one and put it on the outside, because if you took this times x, you'd get 4x squared back and negative 3x back. And that's all you have to do. Here's another. Take 10y cubed plus 20y squared minus 5y. Seems to me they all have a y. And they also have a 5. So if I divide everything by 5y, 10y cubed divided by 5y, well, 10 divided by 5 is 2. 3y minus 1y is y squared. 20 divided by 5 is 4. 2y minus 1y is 1y. And negative 5y divided by 5y is negative 1. So 2y squared plus 4y minus 1. You go ahead and give it a try at this time. Alright, let's see what you got. Did you divide by 15x, I hope? And here is your result. 10x cubed plus 2x squared minus 1. Take a short break. Take a short break. And back. And this, negative 12x squared minus 4, we want to get rid of the negative as well as the 4. So we're going to get rid of divide by negative 4 here and negative 4 here. Now notice how when I divide by negative 4, this negative 12x squared becomes positive 3x squared. And when I divide by negative 4 here, it becomes plus 1. Now you might say, wait a minute, wasn't that minus 4? Well, just treat it as a negative 4. And when you divide by negative 4, it becomes plus 1. That is, by the way, the end. There's nothing more I can pull out because there's no common factors between 3x squared and 1. Important. I want the largest exponent first, and that should be free of the negative. So if I look at this here, negative 12x minus 8x squared, first I'm going to flip it my own choice. I like to put the largest exponent first. Then, what's common between both of them? Well, looks like 4 and x, and I might as well get rid of the negative in front of the x squared. So I'm going to divide by negative 4x to both sides, which makes a result of 2x plus 3. So negative 4 on the outside and 2x plus 3 on the inside. Now for some tougher stuff. Take 7 times x minus 3 minus 2x times x minus 3. Notice how they're both being multiplied by x minus 3. Since they're both being multiplied by x minus 3, 7 and the negative 2x are both being times by x minus 3, I'm simply going to move them together. Again, let me try that again. 7 is being times by x minus 3. Negative 2 is being times by x minus 3. Therefore, negative 2x and 7 are both being multiplied by x minus 3. So I will simply combine these two and put times x minus 3. I'll put the variable first and put negative 2x plus 7, parentheses, are both being times by x minus 3. And I'll remove the multiplication sign, just stick them together. And that's all you have to do. Let's take another for example. Negative 2d is being times by d plus 9. And negative 9 is being times by d plus 9. Since they're both being times by d plus 9, I'll take negative 2d and the negative 9 and combine them times d plus 9. Then remove the times symbol, and there you go. Take a short break. And back. Now, here I have negative t times t squared plus 4 plus t squared plus 4. Now notice there's no number on the outside of this one. However, I can always put a 1 in front of there because it would be the same thing. So I'll put the 1 down here. And now I have negative t and 1 are being times by 2t plus 4. So what you'll do is we're going to go ahead and take negative t plus 1 over here, t squared plus 4 over here. And that's all you have to do. Go ahead and try it this time. I don't care if they're weird symbols. Just do what you know what to do. Let's see if you got it. Negative 6 and sign plus looks like 1. So I went ahead and did that. Negative 6 plus 1. And then I have and squared plus 4, because those are both times and squared plus 4. Now you might say, why is the negative on the outside? Well, let's see. Really, when I have this, this should actually be like this, because I have negative 6 and then plus 1. And the negative should be on the inside, not the outside, so small error there. But this is your finished answer. And this. Go ahead and try. Well, actually, don't try yet. Let me show you something first. You know how x plus 4 and 4 plus x are simply switched? Because they're both in the parenthesis, I can move those around. I can make 4 plus x become x plus 4, and that's okay. It's part of the commutative property. Now, because they're both being times by x plus 4, 9x and negative 5 is, I can put 9x minus 5 times x plus 4. And there you have it. Go ahead and give it a try. Hint, you might want to times this by negative 1 or this by negative 1. Makes no difference. I went ahead and rewrote this. What I did was, I went ahead and times actually I just flipped these. I'm sorry, you don't have times by negative 1. My fault. Just put negative x in front, 4 behind, so negative x plus 4. Whoops, my fault, sorry. So I have 2 and negative 3 c cubed over here, and they're both being times by negative x plus 4, and that's my finished product. Now, if I wanted to go ahead one step further and go ahead and put a positive sign here, how would you do that? Well, I could change this to 3c cubed minus 2 by times by negative 1. And what I mean by that is that way it flips these signs. So now instead of negative 3c cubed becomes positive 3c cubed. Instead of positive 2 becomes negative 2. And I had to pull a negative on the outside though. Then I can take negative x plus 4. Now there's more than one way I could do this. I could go ahead and take this negative 1 times one of these guys. I could just take this negative 1 times both of these and work that out. So I could have 3c cubed minus 2. And I could have positive x minus 4. You're going to find that there's lots of different ways to do this, and which one's the correct way? Well, personally, if given a choice, I like to have positive leading exponents myself, so I'd probably choose to have this here, or maybe have this or this. Your book might have this, but either way, if you get either one of these this far, I'll mark it right. Quick break. Alright, back. And sometimes you can't factor, like this here. 9x times x plus 4, and then negative 5 times b plus 3. Well, they don't have the same, factors here. They don't have the same, anything. You have an x, you have a b. So since the parentheses are not the same, there's nothing I can do. So you put the expression cannot be factored. So in this case, you just can't factor it. Finally, 12a cubed minus 9a squared plus 20a minus 15. This is different because we're going to start by splitting the problem up. I'm going to go ahead and take these two here, the 12a cubed minus 9a squared, and put it over here. Then I'm going to take the 20a minus 15 and put it over here. Now the reason why I do that is because these are so close together. When I pull from these two, I can pull out a lot. I can pull out 3a squared. Notice how I leave 4a minus 3. If I pull out of these two, I pull out of 5, I also have 4a minus 3. Therefore, 4a minus 3 is over there, and 3a squared plus 5 over here. Notice how I can pull them apart, and we have a binomial after all. And we're done with that one. Go ahead and try. Remember to split these up. Go ahead. Notice how I went ahead and broke these down. These two here, these broke this way, these two broke this way. I pulled out 5x to the 7th over here. I pulled out negative 2 out of these guys over here, leaving x plus 3. So 5x to the 7th minus 2 and x plus 3 over here. Quick break. And back. Now, 3x cubed minus 15x squared plus 10 minus 2x. You know, there's a couple ways I could have done this. I probably should have flipped these first, but I didn't, but that's okay. These two break this way, these two break this way. I pull out 3x squared here, leaving x minus 5. I pull out a 2. Notice how I have 5 minus x. I'll simply flip, but if you flip, this negative x still remains negative x, and this positive 5 still remains a positive 5, so I flip, but the signs go with. Now notice how I have negative x plus 5. Well, if I times by negative 1, this becomes x minus 5. Negative x becomes positive 5 becomes negative 5, and 2 times negative 1 becomes negative 2. So this simply becomes negative 2. Negative 2 and then x minus 5. So now I have 3x squared, x minus 5, and negative 2 times x minus 5. Therefore, 3x squared minus 2 is being times by x minus 5. Now, I want to take another step with that. Let me go ahead and copy this again, because I think there's a simpler way for me to do this for you. Although that's perfectly fine. And notice when I start with this, let me go ahead and take 3x cubed here. And I'll take negative 15x squared here. That's no problem. But let me take these two. And over here I'm going to put negative 2x first and positive 10. Notice I just flipped them around. So while I do this, I'm going to go ahead and take out my 3x squared. And that leaves me my x minus 5. And I'm going to go ahead and, in this case, notice how I need to have a positive x. So I'm just going to pull out a negative 2 this way. And it makes x minus 5. And either way, you get 3x squared minus 2. Bad handwriting, I know, but I'm writing with a mouse. And x minus 5 over here. So whichever way makes you happy. You know, whichever method, neither is wrong. And that's that. So this was a little tougher assignment. I do expect some questions tomorrow in class, so do the best you can. Thanks again. We'll talk to you later. Bye.
Here's a trick that street magicians use to make us think that they have freakish powers. A bent bottle top and an empty bottle are all it takes. The magician taps the bottle top against the bottle to prove it's solid. But watch. With the bottle top resting on his fingers, he continues to tap until it's inside the bottle. Now that is freaky. Is this special powers at work or just another menacing mind game? It's very simple. The trick is in the ring he's wearing. It's magnetic and powerful enough to attract the metal bottle top. The other secret is actually 2 bottle tops. When the illusion begins, one cap is already hidden inside the bottle, held in place by the magnetic ring. The cap outside is tossed up from his hand and caught by the ring, while the cap inside is released. It looks as if it's passed through the glass, but we're really just seeing the cap that was inside all along. That's the last time a magician will fool you with that cheating secret of the pros.